actually looked at the visible. Many of those wavelengths, all those wavelengths make it to the surface of the Earth, but not into the infrared. And that's why we needed a new telescope. And that's what the James Webb Space Telescope does. It really hones in on a brand new wavelength regime that we haven't done much with.
So what intrigues me is when I first learned of the James Webb and how it's tuned for the infrared, I being fundamentally a large-scale structure guy of the universe, I was very excited to recognize that it will be able to see the formation of galaxies in the early universe in a band of light that is redshifted into its zone. I mean, it's like the universe is it's like, universe, put it here, universe, and then we got you, right?
Wow.
Right?
Yeah. Well, it's.
The universe is so balanced and so perfect that it's like, no, we're in a shooting gallery.
Oh my goodness!
And so practically every sort of shooting star, by the way, these phrases refer to the same phenomenon: shooting star, falling star, meteor.
Right.
They're all referring to a tiny particle that Earth slams into in our orbit around the sun.
Wow. Right.
And we're going about 18 miles a second. Okay. What's that? That's like 30,000 kilometers a second around the sun. That's fast. And if you're just minding your own business out there in space and Earth slams into you, our atmosphere will look like a brick wall.
Yeah, it's
at
like
that speed.
Yeah, it's kind of like the bug that hits your windshield. You know, that's what these that bug. If you weren't going 70 miles an hour. You know, that bug, at 70 miles an hour, it's like, did that bug just break my windshield? Like,
So you're in space. That's what we want to call that space. Now, you're not weightless, though. People equate being in space with being weightless. You're only weightless if you're in free fall. Okay? So if at that moment he cuts off his engines, and they fall, then you're weightless.
Got you.
For as long as you're falling.
Right.
Okay, but there's a point where the atmosphere gets thick enough again, and in the case of Richard Branson's rocket, it was also an airplane. It had airfoil. So as it starts hitting atmosphere, then the control surfaces of his wings begin to take effect, and then it can actually do a descent as an airplane. But the moment it does that, you are no longer weightless.
Right.
Okay. So I just want to make that clear. The weightlessness is simply for being in free fall, not for being in what people are calling space.
Space.
It's not like you hit space. I'm weightless. Oh my gosh, I'm weightless. No. Are your rockets firing? No. Are you a plane? No. You're just falling. You're weightless over that time. It's just like the parachute drop or whatever it is at the amusement park. When they just drop the floor out under you, you are weightless until some parachute opens. But over that time, you're weightless. Basically weightless. Okay? Here we go. 1905. You should know immediately, one thing should know in your head, 1905. Einstein comes out with this special theory of relativity.
Right.
Okay?
In fact, it's not on fire.
It's not what he called it. It was the paper that delivered it to us is called On the Electrodynamics of Moving Bodies. And no one wanted to recite that, so it's just called special relativity. But that's what it is, because it's all about the relativity of motion and time. Okay? Right. So what it did was codify the fact that spatial dimensions need the three spatial dimensions, height, width, and depth, need a fourth dimension to localize it in any spatial system you're talking about. And since you needed time, then it's a space-time system. So it sounds like it's weird. Like, what are you doing, Einstein? Leave me alone with my height, width, and depth. But it turns out we have always thought about life in 4 dimensions. So, the French came up with the metric system. Did you know this?
No wonder we don't use it.
Where you get this editorial comment? So it got implemented in 1789. And what was happening then in France?
1789.
Yeah.
89.
In part inspired by what happened in the United States.
Was that the Bastille storming and all that good
the
stuff?
French Revolution, yeah.
Right.
Yeah. So part of that sort of overthrowing of all previous order, that was the occasion. If you're going to do it, that's a good time to do it.
Right.
In addition to the rolling heads, you throw in the metric system.
We need to figure out how these heads roll, Father. How is it that we get the head to roll, Father? Do not put the basket down. Let it roll, and we shall measure in a new way.
So you plug things into the wall. Are you asking yourself, I wonder what kind of power this is? Are you even wondering what it costs you? It's actually relatively cheap, all right?
Is, yeah.
Relative. I mean, compared to other things you spend money on, it's so cheap that if you're driving away and you realize, I left the living room light on, are you going to stop the car, turn around, and go back and turn out the light, and then continue to your dinner? No. You just say, I'll turn it out when I go to sleep. When I get home, right? That's how casual we are about this. So you plug it into the wall. You don't know what produced that energy. It could be coal, could be oil, it could be hydro, it could be solar panels, it could be nuclear, it could be tidal. You don't know, and in fact, you don't care. So if laws change, if we run out of oil, whatever goes on in the energy marketplace doesn't have to concern you. The power company says, I will now generate power from wind, from solar, from hydro. By the way, wind and hydroelectric are both solar powered, right? The sun evaporates ocean water and that moves on land. It comes out as rain to some high lake. You dam that, or a river, you dam that, and then you have hydro power. And of course, wind powers the uneven heating of Earth's surface, causing wind movement. So solar panels, wind, and hydro are all solar power, okay? So the electric company, if the price of oil goes high, let's swap in more solar. If we outlaw coal, they bring in hydro, but bring in nuclear. Whatever else it is, they're not beholden to oil to create power that comes out of your wall socket. When you're walking down the sidewalk and you see a worm, do you pause and say, gee, I wonder what that worm is thinking? Gee, let me figure out how this works. No,
you put it on a hook and you go get dinner. That's what you do.
So just to believe that we are so interesting, that something as advanced as a civilization with flying saucers to cross the galaxy would sit there and want to analyze us. So that's hubris, okay? So there's that. But also, consider how many photographs are taken every day. Everybody's got a smartphone, right? Almost everybody. High resolution. And if you're not taking a photo, you're taking a video. And so if there's something unusual and interesting, you're taking a video of that. We have video of stuff you never got videos of before. You'd think an alien encounter would be rare, but you've got a smartphone and you can stream it. In the old days when people said, did you take pictures of the alien that abducted you? Yeah, but they stole the film. Or I got the film home and the whole roll was blank because the alien zapped it or whatever. So it's a recording device, but a streaming device is not a recording device. So you can live stream whatever is happening. All right. So you would expect, given how many reports of abductions there were,
Right.
of decades past, that somebody would have that on, that'd be posted by now, and it hasn't been. So this leads me to think strongly that people's imaginations got the better side of their life experience when they came back to report on having been abducted. So what's happening is, because you're getting spun, you have an urge to fly off at a tangent of that circle. Okay? That urge to fly off that is prevented, you will feel as a centrifugal force. Okay?
Okay.
So if in any moment the walls just disappeared on the cyclone, is it called the cyclone? Whatever that was called. The flying
I forget
saucer.
the name of it, but I do remember.
I think I'm misremembering because Cyclone is the roller coaster at Coney Island.
At Coney Island.
So whatever that thing is, we've all done it, right? Mm-hmm. And if at any instant while that's spinning, the walls just disappeared, you would just fly off at a tangent. Everybody would just fly off going in exactly the tangential direction they were going. Right at the moment the walls disappeared. Okay?
I smell a lawsuit.
Lawsuit.
So in it comes. Particles in Earth's atmosphere that happen to be the same size as the wavelength of light of the blue side of the spectrum, the blue, indigo, purple, violet side of the spectrum. Those particles preferentially scatter the blue out of the sunlight. Preferentially scatters it. So it subtracts away a little bit, just a little bit. All right? The rest of the light makes it all the way to Earth's surface. But some of the blue gets scattered, and that's why we have a blue sky.
Nice.
The blue sky is stolen sunlight that would have otherwise passed straight through.
Look at that.
Okay.
Right, because the sky is really clear, right?
Okay, so now watch.
How beautiful is that, though? Wow.
Now let's have the sun get a little lower in the sky. Well, there'll be more of this going on. Okay, more of the scatter. That's why on cloudless days into sunset, the sun gets deeper and deeper and deeper blue. What I'm saying is, we monitor when we have fell behind by a second.
Okay. So when we know that we've lost a second based on our atomic measurement.
Correct. Then internationally, we say time to throw in a leap second.
Now we throw it in.
By convention, we throw it in on June 30th or on December 31st. And we can throw in one at each time if we needed it. Okay. Right. Since 1973 or 4, something like early 70s, there's been 24 leap seconds added to the calendar.
Sweet.
So when they're going to add a leap second, they choose which of those days it will be. When they do so, that final minute has 61 seconds in it.
Nice.
Yes, it's very cool. It's very cool. And so this is what we do.
That's the longest minute of...
Yes, it's the longest minute because it's actually 61 seconds. Okay, so newspapers like having fun with this. Say, this year will be slightly longer than other years because you have to throw in the leap second. That leap second happens on Greenwich time. So for us, it would take place at like, I guess, 7 p.m.
Right.
Because we're 5 hours behind them.
On the Greenwich Mean Time. Right.
Greenwich Mean Time, right.